Good afternoon and welcome to What's New in Android. I guess this thing is being live streamed, so we should also say good afternoon to everybody else in the world.
Konbanwa, that's right.
Or something like that. I am Chet Haase. I'm on the Android UI Toolkit team.
I'm Dan Sandler. I'm on the Android System UI team in the Boston office. Boston!
And thank you for the overwhelming applause there. That was fantastic. All right, thanks for coming. That's all we got today. Good night. So let's talk about, I don't know, what's new in Android. We want to talk about like API and things like that. Except we had the idea that we should really step it up this year.
We need to be inspirational. We need to, encourage people. We need to open their minds. We need API. Functions worth calling. Sorry, I gotta pose for the picture.
So we're going to talk about, we'd like to talk about all of the new stuff, but it turns out we really don't have the time. We put so much stuff in the slides that we basically spent yesterday ripping out about 2/3 of it.
There's like another whole hour of talk that we could do on like the director's cut.
Yeah, look for the deleted scenes. There are a lot.
Unrated.
Okay, so let's dive right in and talk about some stuff, starting with, let's talk about M. So a lot of people are probably wondering what M stands for. I know we are. Any guesses? Any guesses? My personal guess is, But today, more importantly, M stands for M Developer Preview. So let's talk about how to actually build preview apps. So first of all, get the tool. So go to the site, get the tool, download the SDK and Android Studio 1.3, and you create your project the same way that you always create your project. And then you go in and you modify the project structure. What you're going to do is build against Android M Preview, not surprisingly. And then if you look, you don't have to edit. Please don't edit. Look in your build.gradle file. It'll probably say something like compile SDK version Android MNC. And then you know that you're off and running and you can use the new APIs that we're going to be talking about today. So write the code, and then obviously you're going to test it. There won't be any bugs, but if there are, you can debug it, and then just go ahead and do it again until you're done. An extra thing that we should add is that the preview process this year is a little bit different than the preview process last year. We intend to actually have a couple of different versions out there. So we're going to incorporate the feedback that we get, and we have some issues that we know about that we're working on still internally, fix those bugs, come out with another preview release, fix those bugs from that preview cycle, come out with another release, and then sometime after that dotted line that's sufficiently vague that we're not pinning down a date on that one, we've got a final release. Okay, that's the preview release. Now let's talk about a slew of APIs and features in no particular order.
In no particular order, but we do want to talk about some of the things that you saw in the keynote. And one of the first ones, hopefully this was exciting to all of you, is the changes that we made in app permissions for M to promote all kinds of great stuff around installing and upgrading. So let's take a look at it. You may recall this is what it looks like when somebody wants to install your app today. It is a wall of permissions because if your app has reached a sufficient level of complexity, in addition to being sentient, it has to request basically everything, and the user says, OK, fine, whatever. It's not like I'm not going to install Hangouts, let's say. In M, we push the button. And we see what happens. In M, runtime permissions. So when you install an app, you see none of that. You click install, it downloads, it installs. That's it, completely friction-free. And then when the app wants to go and use some feature of the device, then you get the runtime permission prompt. For an app that is going to use a bunch of permissions, there's some things that without which it doesn't work. If you've got a camera app, it needs the camera. We recommend doing a warm welcome where you ask for all those things up front. But for other kinds of permissions where you only need it occasionally, like recording audio in Keep if you're going to do a voice memo, you can wait till the right time to ask the user. The user has ultimate control over these things. Not only can the user deny them in the moment, but they can go back into settings and find out all the permissions that your app has and all of the apps that have a particular permission and turn them off individually, line item a la carte. So that's a blank slide. It's basically everything that you've ever asked for in Android permissions, and now your app has to deal with it. What does that mean in practice? It means that you can ask for any permission at any time if you're targeting M. If you're not targeting M, you don't get any of this stuff. Legacy apps who are not targeting M, the experience they will get is basically what you have today pre-M. Wall of permissions at install time. There's no other way to do it. Users can go by and, for M apps, deny those permissions at the request time. For legacy apps, they can still go back into settings. For an app that has not been updated to M, if you were on an M device, you can go and turn those permissions off. Even for a legacy app, there's a dialog box in settings that says, whoa, 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 hang on there, Tex. This app has not been updated to M. It might not work right, but the user will still be able to turn those things off. So even if you don't have any plans immediately to rev for M, you need to test your app in the M emulator to find out what happens when those precious permissions get disabled by the user. There is a session. Is it today? Is it tomorrow? It'll be on YouTube regardless.
Might even be both.
Might even be both. Permissions in M, best practices, you definitely want to go to that. They will get into all the nitty-gritty details of how to ask for a permission at runtime, what to do if you don't get it, and so forth.
Actually, for everything that we're talking about today, where there is an applicable session or sandbox talk at the conference, we'll call it out and suggest that you go there for the deeper details. As we said before, we don't have a lot of time to cover things in any deep amount of detail ourselves. So
are you telling me to hurry up? Is that what you're saying?
I think you're telling me to.
I think so.
Let's talk about one of those things that we'll cover very, very quickly, voice interaction. So there is a new thing called Voice Interactor that allows you to interact with the voice input system. So there was already the capability for a voice action of the user to launch an intent and do something with your application. But now you can actually ask for clarifying information or confirmations that become maybe audio responses to the user. So you add this new category to your intent filter, the voice category, and then in your code, you could already do this. You could say, was this a voice interaction? Go ahead and do some stuff. But now you can actually say, well, actually, here's a string to create a prompt out of. Pass this back through creating this confirmation object. You're going to create a voice interaction confirmation request, and then the prompt goes back to the user. They do something with it, and then the information comes back to your activity. You get the appropriate information, take the appropriate action.
Let's talk about fingerprint. We saw a lot of this in the keynote. It's actually pretty simple APIs. There are two major ways to get into it. One, you can talk to the brand new fingerprint manager in the Android hardware package, I believe, and you can say, hey, authenticate. And what this does is it verifies that the authorized user is present and is able to provide one of the multiple enrolled fingers on the fingerprint sensor. So you can enroll, you can say, I want this finger, I want that finger, and this manages to check to see whether the user can provide one of those fingers again on the sensor. But your app controls all of the UI. So if you want something that's branded, if you've got your own fancy animations, you can do all of that. This is all completely behind-the-scenes APIs that you can call to read from the sensor. If, on the other hand, you don't really need to bother with the UI and you just want to make sure that the user is still there, you can use the existing KeyGuard Manager API, create confirm device credential intent, essentially show the lock screen again. Show the lock screen and allow the user to authenticate by whatever means they usually use to get into the device, so a PIN or a password or a pattern, or on devices that support it, a fingerprint. You do this with start activity for result, you check for the OK result, and then you're good to go, and you know that the user is there. We have sample code up on the Google samples section of GitHub, Android fingerprint dialog, Android confirm credential, and there's also a sandbox talk about this today and tomorrow, about fingerprint and payments APIs. We don't have time to talk about pay right now. Go to that sandbox talk, learn more.
Let's talk about backup. So we already back up a bunch of stuff on the system. You get a new device, you get settings that are associated with your account. So we back up things like Wi-Fi settings between devices and accounts. So all of that stuff already works. So the new thing in M is, by default, all the data for all the apps that are targeting M and greater is going to be backed up automatically by default and then stored in the user's account. You have the ability to opt in and out of various portions of that if you want, so we can see some simple sample code here. So you can specify an XML file that's going to live in your XML resource directory and then use these include and exclude tags to say what exactly you want backed up or what exactly you do not want backed up. By default, everything is backed up, but if you use an include tag, then we will only do that. Or everything's backed up and you use exclude tags, and we're going to pull those things out and not back those up at your choice. Again, sandbox talk that you should go to, Unleashing the Power of Android Backup, so check that out in your schedule. Let's talk about Google Play Services. 7.5 is out. I hope it's out. Or maybe we should just delete this slide before I talk about it.
No.
Let's assume that it's out by now. Let's talk about one of the most exciting features there is GCM Network Manager. If anybody's familiar with Job Scheduler, very cool way of of making sure that your network traffic, your network requests are going to be much more optimal for the device in general. You're going to batch these things up. You're only going to do them at certain optimal times when the device is charging, when it's on Wi-Fi, whatever. That was awesome, but it's specific to L. GCM Network Manager takes that same idea and extends it to releases prior to that. So everybody that's opting into the system, it'll be able to batch up all of those requests together. Then on L, it will use the underlying job scheduler technology and APIs, but on previous releases, it uses its own home-rolled animation. I'm talking about animations again, even when
we really can't stop you, can we?
I don't know what implementation. I'm going to use the word implementation instead. That works a little better in this context. I'm going to go with that. So it's going to use its own stuff internally prior to L, and you're going to get similar functionality across many releases. So check that out. Also check out many of the other things in the latest Play Services release. You've got maps on Android Wear, some of the other stuff listed on the slide. More importantly, go to the What's New in Google Play Services session. I believe that's 2 from now this afternoon. So check that out for deeper information.
Let's talk about power. Do you want more power? Sure, we all do. In M, the focus has been on improving battery life, specifically improving screen-off battery life. A device that you're not holding, not plugged in, it should be able to sit there for kind of a long time. In the keynote, you heard about Doze, which is the big new device-wide feature that is helping us with this. Essentially, a device that is untouched for a long period of time becomes inactive. And we're actually using the accelerometer to see if you are actually moving this device around. If it's in your pocket, this doesn't count. But a device that is sitting on the table, sitting on the couch, sitting in a bag for a long period becomes inactive and waits longer and longer to wake up for scheduled repeating events and things like that. Now, as Dave said, if there are real-time alarms, if there are high-priority GCM tickles, things like that, sure, we'll wake the device up immediately. We don't want to miss an important text. But
also earthquakes.
Also earthquakes. Well,
yeah,
okay, so yeah,
all right,
you work on that app to do the accelerometer.
Right.
And then, yeah, okay. And then as soon as you pick up the device, start interacting with it in some way, even plug it in, Doze turns off, the device goes back to syncing as normal. We're going to take the same idea as well and apply it to individual apps that you haven't used for a long period of time. And by long, I mean more on the order of days. We call this app standby. So an app that you installed a long time ago, you kind of forgot about it, you're not using it. After a while, it's going to lose network access and the ability to do other background tasks. So it can't sit there and just continually sip away at the coulombs hiding in your battery. So that app is going to go dormant until you use it again or until the device gets plugged in. Let's talk about what we saw in the keynote as now on tap. In the APIs, you'll see this is called support for an assistant. And in order to talk to the assistant, we have some new APIs that you can look at on activity and applications, so you can provide very specific information that you think is going to be relevant to something like now on tap to be able to provide you just-in-time help for the user. And so what you're going to want to do is see the SDK docs as part of the M preview release to figure out how to use those and integrate those into your app to provide the best data.
Data binding, one of the most exciting features to come out of the toolkit arena right now. This is something, it's an idea that's sort of been around in various forms elsewhere for years, and we're incorporating some of those ideas here, where it's the ability to connect the data model to some of the UI elements in your application. This is something that you do already. An application that's all UI and no data is basically a demo app. That's what I write. I write demo apps. But real applications should actually have data, and when they do, you want to propagate that information to the UI. And when it changes, you need to propagate the changes. And you end up creating listeners, you end up creating property change notifications, you've got setters and getters all over the place in your code. It's not difficult code to write, but it's a lot of tedious boilerplate that you write over and over and over again. Wouldn't it be nice if we could actually do that for you? So that's the idea behind data binding. Let's take this simple example. I think this is an example that's going to be used in the sandbox talk that you should go to. There's one this afternoon and one tomorrow as well. So you've got this idea where you've got some pictures and you have prices associated with the items that are shown in the pictures. So you probably have some item in your recycler view that's binding to some text view and image view. Through data binding, we don't have time to go through the entire example, but I can sort of show you the end result. You end up having this new type of resource file that we've defined called a layout. It's not a view layout, but it's an overall layout that has both the view hierarchy information as well as this section of data that you associate with that view hierarchy. So here you can see that we have the layout file, and then we have this variable. We said, OK, we're going to have this item thing that we're going to call item that we can refer to then within the file. And then we have the image view and the text view that can automatically bind to the data in there. So using this simple language, they can say, OK, give me the field in there and bind to that instead. And they can also do additional processing on that. So they can actually format the string, pick up a string format object from the strings resource file and attach that to extra information associated with several variables. So very powerful, very simple, and also very performant because all of the hard work is actually done at build time. So it takes all the information created in your resource files, pre-processes that into the code that's actually going to run at runtime. So we're not doing anything tricky like using reflection at runtime, which you really wouldn't want to do. Instead, we sort of pre-process this into very efficient mechanisms that work fast enough at runtime for you. So please check out the talk on the feature. Let's talk about some more. Yay, data binding.
Fans of data binding.
Awesome.
We found our crowd. These are our people, Chet.
You know, they should have talked about data binding in the keynote. Because we talked about keynote items, no applause. Data binding, big applause. All right, we're going to go back, we're going to rewind, we're going to redo the keynote, and it's going to be all about data binding. 2.5 hours on data binding.
We'll fix this in post. That's right.
Excellent. All right, UI features. This is sort of a mix of stuff, the most important of which is probably the Android design support library. Again, there's a sandbox talk you should go to find out the specific details there. So with material design, we had lots of suggestions and patterns and said, this is the new way to do things. And then developers went forth and did things. And they wrote a lot of code in the process, trying to figure out, and everybody's doing their own implementation of this and that. What we're trying to do with the design support library is embed some of those practices into these components that we then just give you, and you can use these. Hopefully get up to speed on material design a little bit faster and use our implementation. It's going to be a little more consistent, and it's certainly going to be a little bit easier for you to do that. The first of which is worth mentioning, the coordinator layout. This is something that associates the views, the hierarchy, and then the behaviors of those views in there. Several of the components that we're talking about here plug into the coordinator layout so that they can interact together and sort of participate in this common playground. We have the snack bar component. We've got tab layout widgets. We've got navigation view, text input layout. This is the ability to actually see some text that says what you're supposed to be doing with this thing, as well as some error validation text in there. And then the fab. Everybody always asked us for the fab, and we're like, it's just a circle with a shadow. But apparently they wanted it.
Now it's an inspirational circle with a shadow.
It's very inspirational. I'm inspired. All right, some other random UI changes. There is work ongoing in Recycler View, powerful new replacement-ish for a list view that came out in the last release. So there's other features and functionality going into that, such as swipe to dismiss and drag and drop, and some new animations associated with that. See, animations work there.
They did.
So animations in its implementation. And then we have some changes in WebView, post message, so you can have the ability to interact between WebView and JavaScript and post messages there. We also have more diagnostic capability around WebView clients. And also the ability to pre-render to an off-screen raster in a situation where otherwise it might flicker on the screen during an animation. Takes up more memory. There's a trade-off between memory and preserving those bits more solidly, so you can make the right decision for your application.
And all that stuff is in the SDK docs as well as part of the M-Preview release, I believe.
Yes. Notifications. Why don't you talk about notifications?
You thought you were going to get away without me giving you a notification lecture, but this is my baby. I'm going to talk about notifications. Fortunately, there isn't nearly as much to take in as there was in Lollipop. Lollipop is kind of a bumper crop for us. In M, the first thing I need to explain is a new class Chet let me work in his team's package for a little while and build something called Icon. Icon is not all that complicated. That's why I built it. All it does is hold either a drawable resource, ID, or a bitmap, or a byte array that you promise contains a compressed bitmap of the sort that Bitmap Factory can decode. Why do we need this? Because now, when you build a notification, you can just pass one of these icon objects to set small icon in the builder. You are using the builder, right? Nobody's calling set latest event info anymore.
Who's using the builder?
That's right. That's right.
All right, who's not using the builder?
I'll see you outside.
Get out.
That's right. OK, so great, Dan. So you took what was one line of code, set small icon of a resource ID, and now you've made it 3. Now I have to construct this other icon. By the way, the old set small icon API does still work. We don't deprecate APIs that fast around here. I don't know. How long does it take before we can actually kill a deprecated API?
3 milliseconds? No. Not. No.
17 milliseconds. No, wait, that's a drop. That's a
No,
frame.
We're going to drop a frame. That's
OK,
jank.
that's not good.
Jank
No jank, not on this stage. OK, Dan, why do we bother? Why is this important? I told you that an icon can contain a resource ID. It can also contain a bitmap. you can use a bitmap for the first time as the small icon in a notification. So if you've ever written an app that posts notification icons like these, and you have had to cut 60,000 assets to contain every combination of weather and temperature, although for California users, obviously, you just need the one. Now you can generate these things on the fly using a bitmap. If you download an asset from your web backend or something, an avatar icon or something, and it's a ping, you don't even need to decompress it. So this actually saves memory. This saves time moving things between processes. I'm pretty excited.
Ladies and gentlemen, icons with bitmaps.
There we go. That's right. Sometimes it's the little things.
Who knew?
Who knew? Let's move on.
Let's talk about some tech stuff. A couple of different interesting changes going on there. First of all, the gestures around text selection have been improved, make it a little bit faster to choose things more accurately and more quickly. So you drag the handles out, and as you expand the area, you expand by word, and as you contract by character. So you can have the same precision, but you can also select larger blocks of text much more quickly than you could before. Also, want to point your eyes to the screenshot where you can see the floating palette of actions. This is maybe not such an issue on a small phone screen, but if you're using a large tablet device and you select text way down there and then you have to reach all the way up to the top of the screen to hit the action bar, sometimes it's so tedious for we people that don't actually get much exercise during our coding days. So what we have now are floating palettes, and we've enabled this by default in text view. So you've got a text view up, which this example is from. You select the text, and automatically the floating palette of actions is right there. If you have other views that are not these default text views that we enabled this for, you can set your own action mode, get the same behavior. We also have the ability to process text. So you can create the capability in your activity to receive this information to say, oh, they just selected this text, what would you like to do with it? And you can translate that information, you can replace the word for them, you can send back other suggestions, or you can do other things with the text that got sent in. So check out the new text processing APIs. And also, there was a lot of work done with both performance to enable this higher quality formatting, as well as the formatting itself. So we have the ability to format text much more nicely with hyphenations. And also to shape that text.
Hey,
so
Chet, I think people have been watching for an API for like this for a while.
Have they? So you know what this means?
I do.
All right. All right, well, there it is. All right, we're done. And you may be wondering, why would you want your text in a circular format?
We did this joke already. All right, let's start again.
No.
I'm Dan.
I was doing a different one.
I see.
Parallel jokes, app linking, go.
OK, so app linking, we touched on this a little bit in the keynote. And the problem that we're trying to solve is one that we created with an amazing feature in Android, that is to say intent filters. You as an app can say, by the way, these URLs, I know what to do with them. And you're expecting that the user, having had an app installed that knows how to handle a particular URL subset, can do the right thing with it. But sometimes you have an app and you have a domain, and they're owned by the same developer, and that relationship is stronger. And so app links are about understanding that relationship. And we've got documentation about this on the preview site as well. So what we're going to do with app links, the way that you establish the link that we saw in the keynote, where a URL goes directly to your app if you also control that domain, is you're going to have two files. One, you're going to have a statements declaration. We put that on the website in a well-known location, specifically .well-known. It's a bundle of JSON that includes, among other things, the APK package name and the certificate hash that you extract from KeyTool. You'll note that here in the example, it's HTTP example.com. That'll be HTTPS by the time M is finished. You put this statements JSON up on your web server, and then in your manifest, wow, that jumped quickly. What happened there? There we go. In your manifest, you say Android auto verify. That's all you do. You add that to your existing intent filter that can handle certain URLs, and now we will go and look for that statements.json manifest. From your manifest. So here's what happens at install time. When your app goes in, the package manager looks, sees auto verify, will go to the website, try to pull down statements JSON, match that hash to the signing certificate on your APK, and if everything works out just fine, an app link is created, and now links to those URLs will open in your app without bringing up the intent disambiguation chooser. If anything fails about that, if the website doesn't have statements JSON, if the certificate doesn't match, if the package doesn't match, nothing happens. You revert to the old behavior, and those URLs will pop up an intent chooser that allows you to pick between the browser or the various apps on the device that can handle that URL stem. And of course, as with everything else in M, the user can take control. You can go and review and modify those app links in settings. Got a fan back there.
Can we talk about sharing? Let's talk about direct share, which is the ability to share deeper information about your activity, or specifically deeper links into your activity when appropriate. So wouldn't it be nice if someone clicked on something, it fired an intent, and you actually had some context around that and could actually share something more interesting? So instead of launching your overall chat application, you could actually launch the conversation that was in progress with the contact that they just clicked on. Wouldn't it be nice if you could offer alternatives that appeared in the chooser dialog like this stuff? So here's how you do it through direct share. You provide information with your intent filter about chooser target service. You say, when you're going to do this intent, launch my service. And my service can be defined like this. Say it's a chooser target service. And you're going to implement that service and override this method and say, OK, when this method is called, I'm going to return potentially a list of possible targets, including maybe the overall activity and some of the deeper activities, the deeper links that are appropriate. And then what you're going to get is something more like this, where you have the typical activities at the bottom that were already listed before. We already had this capability, but maybe some of these deeper links up at the top that are more appropriate to the context that the user was actually interested in at the time.
Let's talk a little bit about support for stylus. We actually supported styluses since way back in Ice Cream Sandwich. We've had constants in the motion event APIs to allow you to detect that a particular touch stream is actually not coming from a finger at all, but coming from a stylus tool. We've got buttons that you can query to see if they're being depressed, pressure and size data as well. Now, of course, as many of you know, you can get some of that pressure and size data out of a piece of capacitive glass, but for a stylus, you get accurate information. Unfortunately, until now, this only worked for a wired digitizer like a tablet that you plug in, or a built-in active digitizer like a device with its own pen. So what we've brought in M is a couple of things. First of all, a declaration that you can create a data stream. Let's see, what is it? Bluetooth HID over GATT. If you're a Bluetooth LE person, that means something to you. If
no, bit get over bat.
Chet crashed. We're going to have to restart him. If you send your pressure and button data over the HID protocol, over BLE, Android M will fuse this with touch data on the glass. What this means is you can build a Bluetooth stylus that then is reported as a stylus to any app on any M device that supports Bluetooth LE. You don't need special hardware that's dedicated to that device. The app does not need to be revised to support a particular type of stylus protocol. It just gets touch stream events through motion event, and if you are aware and you care that it's a stylus, you can interrogate that data. So this is stylus support for every app and every M device given the stylus, given the correct hardware on the stylus side. Wow, this is doubled up. Thank you. We've got one more. Yeah, it's taken a couple bumps here. I'm going to need to ask you to do it.
You want me to use that? You need some practice with that clicker.
Ooh, all right. Watch it. I do want to point out that we're also adding a couple revisions to motion event in M to help you deal with styli. For one, we're going to have action button press, action button release, which we didn't have before. Previously, you would have to just check to see what the button state was when you got another motion event. We've also introduced new constants for the primary and secondary stylus button, which map to the secondary and tertiary input device button using the previous API. So if you were looking at secondary before, you're going to get stylus primary. Now it'll all be in the docs. We also have new gesture support. So you can use scale gesture detector to enable a stylus scale gesture. Click the button and drag. It's very much like the tap and a half drag scale gesture that we support in a lot of apps on Android today. And you can also add a listener for specifically when the stylus button gets pressed to make it really easy to do things like picking up objects and drag and drop them. And now is the time for the next slide.
Now let's talk about graphics and media. RenderScript Compute, some incremental changes there. So support for BLAS. Who knows what BLAS is, of course? Basic linear algebra subprograms.
I think there are actually crickets in here. Did you notice?
I think they were dead crickets. Really big matrices for calculating really big things. Allocationless launches, so you can have the size of the kernel that's not directly associated with the data itself, and script groups, more optimizations for launching these things that then will execute together. In the camera API, there's other Camera 2 API changes that we're not going into here. I would suggest you check out the docs to learn more interesting information there. But I did want to mention the new torch capability. It allows you to have flashlight capability in your app without actually owning and running the camera device. It used to be sort of hard-coded, linked with the camera, and you had to get this really heavyweight and battery-sucking thing running when all you really wanted to do was light up the flashlight. Now, it's associated with the camera, but you're not actually running the camera full-time while the flashlight is on. So new simple API to interact with that there. Also some important optimizations in the arena of alpha. This is a really small and subtle thing that ends up being a real performance problem that we see on our group a lot, where people will associate alpha with a text view. Sometimes when people just want gray text, they'll set it to be white, but then they'll set a translucency value on a very large text view, causing performance problems in things like notification panel. When we detect that internally and someone set a translucent value on a view, then we can turn that into a hardware layer automatically, which is a lot faster for us to then just create the layer once, draw to it, and then make that translucent, as opposed to redrawing this external buffer every time we process the drawing for that thing. So we do this automatically. However, we still suggest that you set a layer type manually whenever you actually need it. It's a better approach in general. So you can use the set layer type in View. You can also use the with layer API in View Property Animator. Specifically, the reason to do this is because we're going to create that layer the first time that we know you need it. But if that first time is the first frame of an animation, you're going to suffer a little bit of jank, a little performance hiccup as we create and render that layer. So it's better for you to do it ahead of time than for us to do it automatically for you lazily.
My 4-year-old's favorite color is clear. She's really excited about this new API.
She's so transparent. All right.
Alpha female.
Talk about audio. Quickly. MIDI. So you could already do MIDI if you wanted to do it all by yourself. So you're down there at the USB level, sort of getting the byte stream and doing everything. You could all on your lonesome. So instead, we introduced the new android.media.midi package to do a lot of the heavy lifting for you. So we'll give you the actual byte stream. You still need to figure out what the codes are. That's kind of the way MIDI works. But you can create a device manager. You can create the input and the output port, send information, get information, create a MIDI service that can listen for information coming into the system. And it's important to note it's both sides of the equation. You can have an Android app that is sending the node information out to samples on some external device that are playing those. You can also have a keyboard or other MIDI device connected through USB to the Android device, and it's actually sending the node information in, and maybe your app is actually playing the samples directly. So two-way communication, that's what music's all about. Also, higher resolution audio, there's always work going on in the quality arena. So we have audio samples that are now single precision float instead of the 16-bit samples we had before. We have 96 kilohertz sample rate instead of the 44.1 or 48 kilohertz. And we have multi-channel USB digital audio. So yay. Let's talk a little bit about tools. Android Studio 1.3, they talked about this in the keynote. Integrated testing support, data binding, yay, tooling, especially syntax understanding for some of the new language stuff that you saw in the XML resource file that we were looking at. Some tooling support around vector drawables, new annotations all the time to make it easier to get more type-safe code and more information from the IDE itself, and also Android NDK development. You heard the stuff about native code development within Android Studio. So please go to the next session after this one. Tor and folks were convinced that we were basically the warm-up act for them. So we encourage you to stick around for the lead act in the bands. So go to their session immediately following this one, I believe, in this room. And Systrace. So who agrees with me? This is a simple UI. I get it. It's obvious. All right, one person. Excellent. You, sir, are
That might be Dave Burke, actually.
What's that?
That might be Dave Burke.
It could be. OK, so Systrace is probably the most powerful performance tool that we have. Certainly in the graphics performance arena, it sort of gives you a broad spectrum of here's everything that was going on in the system that we know about at the time when you were experiencing performance problems. But it's difficult sometimes to know what to do with that information because it's, I don't know, some people think this is not obvious to look at this obviously beautiful UI and understand what was actually going on in the system. So what we did was we added even more information to it. Can I borrow that laser pointer? So if you'll see up here, can you give me a laser pointer that works? Here. All right. Those little circles in the middle there are basically tips. You can click on those to get more information about what was actually going on. So we're pre-processing the information there to diagnose some of the common performance problems that we've seen and explain to you what's actually going on so that you have something more actionable to do besides staring at your Systrace output. So here's an example. So you might click on that red button down there, and you might get something like this. So you're going to click on the red button, and it's going to highlight the things that it's analyzing, the problems that it saw, and then it's going to give you a little annotation down at the bottom and say, OK, here was the problem that we diagnosed there. You are actually doing inflation. You're stalling the UI thread while you're doing this. This is a bad thing to do. Shame on you. And then over on the right, we have a summary of all of the problems that we saw, sort of buckets of the various problems. In general, what we see in diagnosing applications internally is that by fixing a couple of key problems, you're going to knock out most of these problems. It's like when you get compilation errors, and there's like 4,000 compilation errors, and then you fix one bug, and now you're down to only 3,947. So there are several common problems that you might run into that are sort of sourced in one problem area. So check out the buckets, check out the notations there, and go optimize your application, please.
Let's talk a little bit about the compiler. I remember my grad compilers class, which means that I sort of remember what these things are. The art team is continually working on improving the new runtime. The upshot of all this stuff, the register allocator, and things like this, the inlining and so forth, the biggest impact, in addition to just faster running code, is improved memory use, particularly on low-end devices. Every time they improve one of these things, you get back megabytes of memory in your process. It's really important. We also have a new get runtime stat API inside Art, so that you can go and actually find out a little bit of the details about what's going on in the runtime.
And some other stuff that we really couldn't find appropriate categories for. We'll go through this really quickly. External storage, the ability to adopt permanent storage as one of the devices that you want to use in the system. And so users can do this and then move things around there. The important key is, well, two things. One is there's no new APIs. You don't need to do anything, but you do need to test. So make sure that you're not hard coding the locations of your app or your app data or other resources that you're using, because what happens if the user adopts one of these devices, moves stuff around, and your app can no longer find what it needs to function. So there are no preview devices with this capability right now, because the devices that we have system images for don't have these devices that you can actually adopt permanently, these permanent USB devices. So instead, you can attach temporary USB storage and test it with the commands that we have down here, the set prop persist fw force adoptable 1. But that's obvious, isn't it? All right, developing for Android. OK, so I pushed this right before the talk, and probably right after the talk, I'll find out that I shouldn't have. But in the meantime, you can check this out. So a lot of the folks in the platform team, runtime folks, some apps folks, framework, UI toolkit, got together. People will ask us questions all the time about, the best approach for doing this or that, or we find out about, ways that people are accessing memory, or creating objects, or hitting the network, or whatever. And we say, don't do it like that. And then they would say, well, how should we do it instead? So we don't like to answer those questions because we're really busy. So instead, eventually, we got together and we wrote an incredibly long article with our brain dump of a lot of the basic rules that people should know about. And we put this into an article that was entirely too long to publish in its entirety. So we broke it into chapters, and we pushed the first two right before this talk. They're on medium.com in the new Google Developers channel community thing. It's on the new Google Developers thing on medium.com. Please check those out. We'll be pushing the rest of the chapters in the next few days. And you can follow us on G+ to find out where they are, or just go to the Google Developers community and you will see them there. So what are you waiting for besides the end of this talk? Please go check out the preview. Please download the bits for the SDK as well as Android Studio. Get the system image and flash appropriate devices. Please report bugs. The whole point of having preview releases is not just to tease you with what we're working on. It's actually to have you run it in situations that we may not be testing internally, and then to get the feedback from you about what you need or what problems you saw. And then finally, we mentioned the sandbox talks and the sessions at Google I/O. But the dev bytes are maybe even more important than the sandbox talks, because those are actually going to be recorded and pushed out over the next, 100 days or something. There's going to be a lot of dev bytes around a lot of the technical details and things that we talked about today. So please check those out on the Google Developers channel, starting now and then going through the summer. And I believe that's it. We have 1 minute and 10 seconds for questions,
I don't
and probably
think
zero
that's really going to
time
happen.
for
People are going to
answers.
take that long to get up to the microphone.
Yeah. So,
however, we will be out on the floor. We'll be out in the playground area. We're taking questions. Please go to the sandbox talks that we mentioned. Please look up the dev bites, and then.
and also, please give feedback on this session and all the sessions that you're seeing at the conference. Go into the app or go onto the I/O website, and you can do it directly in the session pages there. And I think that's it. Thanks for coming.
Thank you very much.